Chapter 1, Section 2, we're doing measures of central tendency. And a lot of this you've seen before, there's probably some new stuff too, so I'd stick with the video. But what we're talking about with measures of central tendency is what are different ways that you could come up with a number that represents a big group. Like if you were to try to get the shoe size of all of the kids at Calvin College. What's the one number that represents the shoe size of your normal college freshman male or something like that? Instead of like listing out like, here's 1,000 different numbers, it doesn't do you any good to have all those. Okay, I digress. So measures of central tendency, really we're just talking about, with this here, it's a single number that summarizes a set of data. Okay, so for these, mean, you've seen this before probably for sure. Normal people call mean the average. And when you find the mean, you take and you add all the numbers together. So we call that the sum of the numbers. And I'm going to do the hashtags symbol for numbers. So the sum of the numbers, take all the numbers, add them together, and then you divide that by the number of numbers. So for example, if you were in class, I'd probably ask for some ages of students, and I'm just going to say we have a 12-year-old couple, or 12-year-old, one 13-year-old, two 14-year-olds. So if we were to try to do the average of that, we'd take and we add those numbers together. So we have a 12-year-old plus a 13-year-old plus two 14-year-olds. So plus 14 plus 14. So first step is take those four ages, add them together, and then we're going to divide that by the number of numbers. Well, there's four ages there, so we're going to divide by 4. So if we add them up, we get 53. 53 divided by 4 gives us 13.25. So you could say, well, the average age of students in this class is 13.25. And you probably would want to get more ages, like everybody's age, but it makes it faster. Well, if we were to take and throw me in that group, well, what's the average age of the people in the class? Well, I'm going to take the same 4 kids. So I have the 12-year-old, 13-year-old, two 14-year-olds. And I'm the young age of 43. And if we take now, instead of dividing by 4, we have to divide by 5. So now there's 5 ages in there. So total all those up, now we have a 96 divided by 5, which says 19.2. Well, if you're looking around your average pre-algebra room, I really hope the average age isn't 19.2. That'd be, that's pretty bad. So we see that in this case, the average or the mean works well in our first one, where all the numbers are pretty close together. Mean works pretty well, but you start having a number that's far apart, your average suddenly doesn't really represent the group very well. And this number here, my age, is what we call an outlier. So an outlier is going to be one of these right here. So the 43, an outlier is an extreme value, and by that we just mean to say it's far away from most of the other numbers. So if you have an outlier, that does definitely make an impact on the mean. Well, for this, the median, median is going to be the middle number. So if you think of where else do you see median? Medians, for me, I think of like on the highway, the median's the middle part. So if you if your brain goes that same direction, you can remember, well, median has to be the middle, because like middle of the highway. So it's the middle number. Now I'm just going to put this little star thing here. It's better for data with outliers. So better for data with outliers. And if we were to take and look at the numbers that we had before, Well, if we want the middle number, first thing that people sometimes mess up is you need to write them in order. And fortunately, I already did that here. I have them in order. So the middle number is going to be this 14. So if you were to say, okay, what's the median age of people in an algebra class, even though you have me in here, the 14 still makes sense. It's real close to, pretty much all the students in the class. So that's what I mean by better for data with outliers. So, all right, if we're looking at these, wanted to do two examples. So this first one is kind of trying to show the point about you got to put them in order or things get hairy. So first step is 4 is my smallest. Sometimes you see people make mistakes, so I often will either cross out the numbers as I write them in or underline them. Sometimes underlining's nice because then you can see them easier still. But here's another example of one that has an outlier, the 90. And now for looking at, well, what's going to be our middle number? Well, I have a 4 and a 90, so 1 off each end, a 6 and an 8. So the middle is going to be 7. So 7 equals the median. And again, you see here the outlier doesn't really matter. All right, if we look at our next one, the next one is going to be a little bit different because now we have, take a cross off the first and the last, the second and second to last, and so on. Now we find we have two numbers that are kind of tied for the middle. So when we have something like that, if two tie, so I'm just going to write if two tie, put tie in quotes, kind of weird how I'm using the word, but if two tie for the middle, average them. Or since I'm doing math, I probably should say, find the mean of the two data, but blah, blah, blah. Okay, so for averaging them, most of you would probably look at it and say, oh, it's 3.5, but sometimes it's not as easy to do it. Average or mean, again, you add them together, divide by the number of numbers. In this case, we'll always be dividing by 2. So we get 7 divided by 2, or 3.5 then, would be the median. All right, so we knocked 2 of these out of the gate. We have the mean, or the average. We have the median, which is the middle. The last thing is the mode. And the mode is going to be the most common number. So if 2 or more numbers tie, then both are the mode. I was tempted to say all are the mode, but then it could be interpreted as though all of the numbers are the mode. But so if we would take and look at this here, in our first group, list them in order makes it a whole lot easier. But you see that I have 2 2s. I don't have 2 of any other number in the data set, so the mode then is going to be 2. For my next one, if we're looking at those there, I have 2 2s again. 2 2, okay. Then I have 2 4s, so the mode is 2 and 4 for those. Now the very last one, I have 1 1, 1 5, 1 7, 1 9. So I don't have any that's repeated more than 1. So you could interpret it as though, oh, they all tie, so they're all the mode, but it doesn't actually work that way. So I should add up here, if no numbers, so if no numbers occur more than once, there is no mode. So if you have a bunch that tie, they all are in there twice, or they're all in there 3 times, and those numbers would be the mode. But if you have it where everyone's just listed once, no mode at all. So that's it for the new stuff. Kind of listed out the learning targets here at the end. So those are the things that in theory you can do. Actually, maybe I will go back and actually write no mode here after the example. But down to the learning targets, that's what you should be able to do from this section. There's the assignment, unless I gave you something different in class. Have fun.